Hello everyone, hope you are all doing well. In this video I'm going to explain this DSA problem, minimize the heights to. So let's get started. Here it is given an array ARR denoting the heights of n towers and a positive integer k. We will given an array of size n and another integer k. For each tower you must perform exactly one of the following operations exactly once. So we can increase the height of the tower by k and we can decrease the height of the tower by value k. Find out minimum possible difference between the height of shortest and tallest towers after you have modified each tower. You can find a slight modification of the problem here. There is some other problem related to this problem, and it is saying it is compulsory to increase or decrease the height by k for each tower. After the operation, the resultant array should not contain any negative integers. So we will keep in mind that after applying all these operations, there should be no negative integers in our array. Now let me explain this problem statement through this example where k is equal to 2 and n is equals to 4. K is equals to 2, n is equals to 4, where k is an integer and n is the size of the given array. Here array is 1 5 8 10, 1 5 8 10. So let me try randomly by my intuition for subtracting and adding this value k to each element. Let me add here so that it will increase. So adding 2 to 1 will become 3, and let me subtract 2 from here, it will become 3. Let me subtract 2 from here also, it will become 8 minus 2 6. If I subtract 2 from 10, then it will become 8. Now which is the largest element in this array? This. Which is the smallest element? 3. And as mentioned in the question, there are no negative integers in our array, so we can consider this array, and we have to tell the difference between the maximum and minimum element present in this array, which is 8 minus 3 5. Let us see if it is a correct answer that I randomly find out. Yes, it is correct answer. So the problem is here, I hope that you understood the problem statement. Now problem is there that how do I know where I have to add k and where I have to subtract k? I don't know. So for that purpose, let me explain you. So consider this array. I'm not taking exact values, I'm taking a b c d, and this is in sorted array. This is an sorted array. Then it must be smallest of this array, this must be smallest element, and this must be largest element of this array. If I now calculate the difference between the largest and smallest element here, it will be d minus a. I can surely say that I have not applied any operation here. I got this difference between the largest and smallest element. So the final answer after applying operation will not become larger than this value, as I have to minimize it. So the final answer will be less than or equal to this value. Now right, it must be clear now. So first I will find this maximum possible difference between the largest and smallest element of the given array, that will be d minus a. After finding out this, I will search if I get a value even smaller than this, then I will replace that value with this value, and again I will search in the rest of the array. So I will start with this, then I will start traversing this array. You must be knowing that if I have a sorted array, let us suppose I have a sorted array 2, 5, 7, 10. If I tell you that find out the minimum difference between any two elements in this array, then we will find the difference between these adjacent elements. I will find difference between 2 and 5, that is 3, and 5 and 7, that is 2, and 7 and 10, that is 3. The final minimum difference between any two elements in this array will be minimum of these values. Here I don't need to find the difference between 2 and 7, 2 and 10, because I know that the minimum difference can be found between any two adjacent values when the array is sorted. Similarly, in this case, if I want to find the minimum difference of the smallest and largest element in the array, it can be found between the adjacent elements. But I cannot consider if one of them is not largest and one of them is not smallest. So for for finding out that, I will first try to maximize it, and I will try to maximize it, I will try to increase it, and I will try to decrease it. If I have two values where A is smaller than B, then for reducing the difference, I can add something here and I can reduce something here. Similarly, for the same purpose, I am increasing it and decreasing it so that the difference between them decreases with the value that is given in the problem, that is k. When increasing it, it will surely become larger than this b, because at the same time I am decreasing this and I am increasing this. It can attain a value of the largest element or even greater than this largest element. If it becomes greater than this value, the largest value here, and by decreasing value k from this element, if it becomes smaller than the smallest value in this array, if both the thing happen, then I will consider their difference, that is a plus k minus b minus k. If this value comes out to be smaller than our this value that we have previously calculated, then I will replace this value with this value. After that, I have calculated for this adjacent pair. After that, I will calculate for this adjacent pair, and I will perform the same operation with this adjacent pair, and the minimum value of all these operations will be the answer. Now let us see the code. As discussed earlier, I am here sorting the array. After sorting, I am calculating the maximum difference that I can get by subtracting the first element of the array with the last element of the array. And now in this for loop, I am going to try to reduce this value res. In this for loop, I am traversing through the array, and I am started with 1. I am not starting with this 0 because I am doing here I minus 1, so it will go out of bounds if I start with 0. After this, I am checking here this condition, if array of I is greater than equals to k, because here it is mentioned that resultant array should not contain any negative integers. Here it can become negative if it comes out to be negative, and already minimum function is there, so it will take this minimum value and negative value. So I don't want to do that. Hence I have put here a condition that when array of I is greater than equals to k. Now I have calculated this for the element on which I am particularly presently currently present, and after that in the max element I am calculating for the previous element. If am present currently at this element, then I am trying to minimize it and maximize it. So here I am trying to minimize ARR I by doing ARR I minus k, and I am going to maximize ARR I minus 1, that is its previous element, by increasing it with k. If any one of these two values becomes smaller, if this value becomes smaller than the previous smaller value, previous minimum value, then I will consider this value as the final minimum of current minimum smallest value of my array. Here also, if it becomes greater than the current greatest value of the array, then I will consider this as the current greatest element of the array, and I will put it in variable max. And here I am again and again finding out the difference and comparing it with my value, previous value res. If it comes out to be less than res, then I will update my res with this value, and here I am returning my result. So this is the code. Let's try to run it. Yes, all the test cases are passed successfully. Hope you understood the concept. Thank you.